Greetings, fellow adventurers, and welcome back to my channel. We extend a warm welcome to you as we discuss and analyze guided missiles of India in this video. India has studied, produced, and used various strategic and tactical missile systems since its independence. Decades-long projects have realized development of all types of missile systems, including ballistic, cruise, anti-ship, air defense, air-to-air, and anti-missile systems. India is one of 7 countries in the world with intercontinental ballistic missiles (ICBMs) and one of 4 countries with anti-ballistic missile systems. Since 2016, India has been a member of Missile Technology Control Regime (MTCR). The use of rockets for warfare in India has been recorded in as early as the 18th century. Mysorean rockets were the first iron-cased rockets in the world that were successfully deployed for military use. Mysore's conflict with East India Company exposed British to the technology, leading to development of Congreve rockets and introduction of rocketry in Europe. Research in missile technology resumed again after India's independence, along with the weapons of mass destruction. Development of nuclear weapons was followed by various missile programs with development of various ballistic, cruise, surface-to-air, anti-ballistic missile and orbital launch systems. India conducted its first nuclear test and initiated with Project Devil as an attempt to reverse engineer Soviet surface-to-air missile SA-2 guideline, and Project Valiant to develop an intercontinental ballistic missile. However, it could not succeed, and experience gained led to development of Prithvi series of short-range ballistic missiles. In earlies, India conducted its first successful orbital launch and synchronized its research institutions under IGMDP and successfully developed a series of strategic missile systems. The project began in early years and ended in 2008, after these strategic missiles were successfully developed. The last major missile developed under the program was the AGNI-3 intermediate-range ballistic missile, which was successfully tested on 9 July 2007. Since then, India has developed, tested, operationalized, and is developing several missile systems that are limited to only a handful of countries, including ICBMs, SATs, SUBMs, and hypersonic weapon systems. Threats posed by enemy missile systems led to the pursuit of Indian Ballistic Missile Defense Program. In 2017, India produced most of defined MTCR-defined missile technologies required to be integrated to produce most missile systems. As per G. Satish Reddy, India achieved complete self-reliance in missile technology. Moving forward, we'll be taking a closer look at Kingdom of Mysore. Mysorean rockets were the first iron-cased rockets that were successfully deployed for military use. Kingdom of Mysore utilized them effectively in the conflicts against the British East India Company. In addition, wheeled rocket launchers capable of launching 5 to 10 rockets almost simultaneously were used in war. These rockets were re-engineered as Congreve rockets by British, opening the door of development of advanced rocketry further in Europe. Without wasting any more time, let's jump into the fascinating world of post-independence. Indian government constituted a Special Weapons Development Team in 1958 to study guided missile systems. The Phase I of missile program was limited to development of a first-generation anti-tank guided missile AGM by DRDO. Liquid fuel rocket engines based on Soviet missile system SA-2 were developed. Despite the overall failure of DRDO to develop a reliable AGM, Indian laboratories had established facilities useful for machining and fabricating various parts of missile systems, including gyroscopes, actuators, silver oxide zinc batteries, booster and sustainer motors, airframe hardware such as fiberglass wings, ground launcher mechanisms, and wire spool winding and reeling mechanisms. India later accepted the French offer to produce SSERB anti-tank guided missiles in ERS. In another phase initiated in ERS, Project Devil to reverse engineer Soviet SA-2 guideline, and Project Valiant to develop an intercontinental ballistic missile ended up with limited success, but imparting experience and facilities for further research on missiles and space rockets. DRDO simultaneously focused on building a guidance package, an essential part of a long-range missile that determines its path and accuracy to hit a target. A platform-based inertial navigation system (INS) was developed and tested on board a Navarro aircraft. Subsequently, an INS was built for both missiles and an aircraft, and this was tested in 1979 on board a Canberra aircraft. Decade of years witnessed India gaining significant grounds in rocket technology, and various technology demonstration programs began, which became the basis of modern rocket systems in India. DRDL had developed competencies in the fields of propulsion, navigation, and manufacture of materials. Indian Space Research Organisation had successfully tested India's first orbital rocket SLV-3 in 1980, whose first stage was used in AGNI ballistic missile for technological demonstration of AGNI missile family. This subsequently led to the birth of the Integrated Guided Missile Development Program, and Dr. Abdul Kalam, who had previously been a project director for the SLV-3 program at ISRO, was inducted as the DRDL director in 1983 to conceive and lead it. He decided that DRDL would pursue multiple projects in this area simultaneously. Thus, 4 projects were born under the IGMDP: Short-Range Surface-to-Surface Missile code-named Prithvi, Short-Range Low-Level Surface-to-Air Missile code-named TRISHUL, Medium-Range Surface-to-Air Missile code-named Akash, and Third-Generation Anti-Tank Missile code-named NAG. The AGNI missile was initially conceived in the IGMDP as a technology demonstrator project in the form of a ray entry vehicle, and was later upgraded to a ballistic missile with different ranges. As part of this program, the interim test range at Mysore in Orissa was also developed for missile testing. The 4th phase of India's missile program stretched from mid-years to early 21st century. BUP's tendency to nuclearize India's military has boosted the development and production of missiles. The phase has witnessed limited series production of DRDO's missiles and their deployment in battlefields. DRDO further embarked on programs in developing submarine-launched ballistic missile Sagarika, cruise missiles BRAHMOS, naval variant of Prithvi Dhanush. Spanning from years to years, India's missile programs have transitioned into a self-sustaining character. Over the period from then, India has made improvements in technology of its missile systems and has produced many missile systems, including ICBMs, anti-ballistic missiles, air-to-air missiles, cruise missiles, and other systems. In this chapter, we'll be shedding light on diplomatic and technological hurdles and its role in shaping our understanding. After India test-fired the first Prithvi missile in 1988 and the AGNI missile in 1989, the Missile Technology Control Regime, then an informal grouping established in 1987 by Canada, France, Germany, Italy, Japan, the United Kingdom, and the United States, decided to restrict access to any technology that would help India in its missile development program. Some of the major technology which was denied included phase shifters for the phased array radars for Akash, denied by the USA. Magnesium alloy used in Prithvi's wings, denied by Germany. Servo valves needed for the electro-hydraulic control systems of AGNI and Prithvi. Gyroscopes and accelerometers, denied by France. Processors: Intel said it would not give India chips for the computers used in Prithvi and AGNI. To counter the MTCR, the IGMDP team formed a consortium of DRDO laboratories, industries, and academic institutions to build these subsystems, components, and materials. Though this slowed down the progress of the program, India successfully developed indigenously all the restricted components denied to it by the MTCR. In 2011, the DRDO chief V. Kelvin Saraswat had stated that indigenous content in India's strategic missiles had gone up to such a level, with ring laser gyros, composite rocket motors, micro-navigation systems, etc., that no technology control regime could derail them any longer. Now, let's shift our perspective and explore DRDO anti-tank missile from a different angle. In 1959, Indian agencies conducted feasibility study to develop a first-generation Y-guided anti-tank missile, DRDO anti-tank missile. Sino-Indian War in 1962 induced the government to fund the project. Designing and wind tunnel tests went on to develop an ATGM of a range of 0.5 to 2 km with flight speed of about 90 ms. The missile was terminated eventually in 1969 once Indian Army upgraded its requirements of an ATGM of range from 1.6 km to 2 km. Prepare yourself for an eye-opening discussion on Project Devil surface-to-air missile in the upcoming portion of this video. The aim of Project Devil was to reverse-engineer Soviet SA-2 guideline missile to produce an indigenous short-range surface-to-air missile. The program initially waned in favor of Project Valiant but was revived later after 1974. Although DRDO had developed and tested various systems for the missile, it later was completely cancelled in 1980 due to disputes between officials and technologies were utilized in other missile programs. In the next portion, we'll be immersing ourselves in the realm of Project Valiant, intercontinental ballistic missile, and examining its broader implications. Project Valiant was one of two early liquid-fueled missile projects developed by India, along with Project Devil in the URSS. The goal of Project Valiant was to produce an ICBM with 30-ton engines and a range of. Valiant missile was envisaged as an 85 tons liquid-fueled three-staged ICBM. The missile, though, could reach near the stages of grounding testing. DRDO's interest in program waned due to internal disputes. ISRO was later approached with an offer to use missile for civilian uses, which they declined, leading to overall closure of the project. Although discontinued in 1974 without achieving full success, Project Valiant, like Project Devil, helped in the development of the Prithvi missile in the URSS. Though never reached fruition, the projects were important precursors to the Prithvi missile developed in the URSS. Let's now turn our gaze towards TRISHUL and explore the fascinating connections it has to offer. TRISHUL was a short-range surface-to-air missile to be used against low-flying and sea-skimming targets. The range of the missile is 12 km and is fitted with a 15 km warhead. The overall weight of the missile is 130 kg. Due to delay in development time and various deficiencies, TRISHUL could never enter production and service beyond testing and was substituted by Israeli Barak 1 missile. The project was officially closed in 2008 and DRDO embarked on more surface-to-air missile programs later. The time has come to unravel the secrets behind Integrated Guided Missile Development Program and gain a deeper understanding. The Integrated Guided Missile Development Program (IGNDP) was a Ministry of Defense India program for the research and development of a comprehensive range of missiles. The program was managed by the Defense Research and Development Organization (DRDO) and Ordnance Factories Board in partnership with other Indian government research organizations. The program envisaged development of 5 strategic systems: Prithvi series of short-ranged ballistic missiles, TRISHUL low-altitude, short-range surface-to-air missile, Akash medium-range surface-to-air missile, and NAG third-generation anti-tank guided missile, followed by AGNI series of medium and long-range ballistic missiles. The project began in early URSS and ended in 2008 after these strategic missiles were successfully developed. The last major missile developed under the program was the AGNI 3 intermediate-range ballistic missile, which was successfully tested on 9 July 2007. On 8 January 2008, the DRDO formally announced the successful completion of the IGNDP. It added that the Strategic Integrated Guided Missile Program was completed with its design objectives achieved, since most of the missiles in the program had been developed and inducted by the Indian Armed Forces. Further variants of Prithvi missile, Akash NG, AGNI 4, AGNI V, AGNI VI and AGNI-based Kelvin missile family went ahead later as independent projects. Get ready to uncover the mysteries surrounding Akash as we navigate its intriguing terrain. Akash is a medium-range mobile surface-to-air missile system developed by the Defense Research and Development Organization (DRDO), Ordnance Factories Board, and Bharat Electronics Limited (BEL) in India. The missile system can target aircraft, cruise missiles, air-to-surface missiles and ballistic missiles up to 30 to 60 kilometers away, at altitudes up to 18,000 meters. Variants like Akash and Akash-NG have longer ranges, higher accuracy, higher mobility and lower reaction time. With our foundation established, it's time to explore anti-tank missiles and its relevance to our overarching theme. NAG, also referred as Prospina, is the currently serving third-generation fire and forget anti-tank guided missile developed under the Integrated Guided Missile Development Program IGMDP. NAG has been developed at a cost of. NAG has an operational range from 500 meters to and first shot hit probability exceeding 90%. NAG also has its man-portable, helicopter-mounted, standoff and IFV-mounted versions. Besides NAG, Bill's Armada series is currently undergoing trials and will have land attack, man-portable and air-launched variants. Armament Research and Development Establishment (ARDE) is testing a laser-guided, tank gun-launched SAMHO missile able to destroy tanks and low-flying helicopters. Besides state-run programs, Indian private firms have been emerging with AGM systems. Now, let's delve into the intricacies of tactical ballistic missiles and explore its various aspects. Prithvi missiles were tactical surface-to-surface short-range ballistic missiles (SRBM) and were first ballistic missiles to be developed and enter service in India. It goes from Prithvi ISS 150 with range to Prithvi IISS 250 and Prithvi IISS 350 with ranges of up to. Dhanush or Navalist Prithvi is a system consisting of a stabilization platform bow and the missile arrow. It is intended for the Indian Navy to be fired from ships against other ships or land targets. Dhanush can fire modified versions of Prithvi II or Prithvi III with ranges high as. Solid-fueled Praha and Pranush are being tested to replace existing Prithvi missiles. Export variant Pragati was exhibited in South Korea in 2013 but didn't receive any orders. Pralay is another battlefield range ballistic missile with better range being developed from PDV anti-ballistic missile. As we venture forward, let's examine AGNI series and SURYA in detail and gain a deeper appreciation for its significance. The AGNI missile series began as a re-entry vehicle project later rechristened as AGNI Technology Demonstrator in the IGMDP. It subsequently gave rise to the series of India's medium-range, intermediate-range and intercontinental ballistic missiles. AGNI-I, AGNI-II and AGNI-III missiles were developed under the Integrated Guided Missile Development Program. Longer-range AGNI-IV and AGNI-V with intercontinental ranges and MIRV emerged in early years as separate projects. AGNI-P, an upgraded successor of AGNI-I and AGNI-II, was tested in 2021 with ability to carry maneuverable re-entry vehicle MARV. AGNI-P has improved propellant, navigation and guided systems and reportedly can be used as an ASBM against aircraft carriers. AGNI-VI is another intercontinental ballistic missile reported to be in rudimentary stages of development by India, and until May 2012 was not officially confirmed by either the Government of India or the DRDO. Reportedly, it will be able to be launched from submarines or from land and to strike a target of over 10,000 kilometers with MIRV-ed warheads. Top DRDO scientists have previously asserted that India has almost all the equipment and technology needed to develop ICBMs, but where the warhead should go or what the range should be will have to be a political call. In 1995, in a report published by Magazine Non-Proliferation Review, DRDO was working on an ICBM called SURYA with a range of. Although, the actual status of missile always remained unknown in public domain. Sources have speculated that AGNI-VI might be SURYA under new codenym. Let's now shift our focus to K-series and explore the ways in which it shapes our perspective. Kelvin named after Abdul Kalam are submarine launch ballistic missiles SLBM of India. SLBM variants of AGNI missiles meant to arm India's nuclear submarines. Their ranges vary from medium-range K-15 to intercontinental range K-6 missile. The SURYA missile is a land attack variant of K-15 missile. The missile has a hypersonic speed and a hybrid ballistic cruise trajectory. Now, let's redirect our focus towards BRAHMOS and discover its significance in our narrative. BRAHMOS, also known as PJ-10, are supersonic to hypersonic cruise missiles developed in collaboration between India and Russia. BRAHMOS have land attack, ship and submarine launched and air-launched versions and are the fastest cruise missiles in world in operation. The existing versions of missiles include supersonic land attack, anti-ship ship-launched versions. Meanwhile, longer-range, hypersonic and air-launched versions are under development. As we enter this new phase, let's analyze other cruise missile programs from different angles and evaluate its significance. Nabhe is the Indian long-range subsonic cruise missile under development and testing, expecting its air and submarine-launched version after trials. It was successfully test-fired for second time from Balasore, Orissa, able to travel at speed of 0.6-0.9 Mach. However, its test on 12 October 2020 failed due to a technical snag. It has succeeded in other tests before and has been approved for limited production in 2020. An upgraded version of the missile is reportedly under development. It is currently deployed on LAC in limited numbers since 2020 due to 2020 China-India standoff. Nabhe project is now technically closed after completing 6 developmental trials. The next phase of tests will happen from April 2020 under a new name called Indigenous Technology Cruise Missile ICBM. It will include short turbofan engine STFE developed by Gas Turbine Research Establishment GTRE and a radio frequency RF seeker from Research Center Emirat RCI. A separate air-launched variant and submarine-launched variant is under active development. Several cruise missile systems are expected to be introduced from experience gained with Nabhe. Now, we shift our focus to Astra, a topic that deserves our attention. Astra are India's 5th generation beyond visual range active radar homing air-to-air missile series. The current version in service has a range from to similar to AIM 120 AIM, while versions up to and intermediate ranges are being developed. A surface-to-air missile variant BLSRSAM has also been developed from Astra to replace Indian Navy's Barak 1 missile with supplementary Akash missile systems along. It forms a surface-to-air missile system similar to American NASAM-2. In the next segment, we'll be exploring Indian ballistic missile defense program and its implications for our subject matter. In wake of missile threats from China and Pakistan, the development of anti-ballistic missiles began in the late years. The program consists of multiple phases and components. Phase I of program is a double-tiered system consisting of 2 land and sea-based interceptor missiles, namely the Prithvi Air Defense PAD missile for high-altitude interception, and the Advanced Air Defense AAD missile for lower-altitude interception. The 2-tiered shield should be able to intercept any incoming missile launched from 5,000 kilometers away. The system also includes an overlapping network of early warning and tracking radars, as well as command and control posts. Phase I is awaiting government's approval for installation over national capital. Phase I would include more potent AD-1 and AD-2 anti-ballistic missiles capable of engaging without ICBMs and hypersonic cruise missiles. Prithvi Defense Vehicle PDV-1 and II are also under trials to intercept missiles at higher altitude and longer ranges and replace existing PAD. PDV-2 has also demonstrated anti-satellite capability. Get ready for a captivating exploration as we unravel the layers of other systems and their profound significance. Hypersonic Technology Demonstrator Vehicle HSTDV is a technology demonstrator aimed to demonstrate autonomous flight of a scramjet integrated vehicle using ethylene. The technology is expected to become the basis of India's hypersonic missiles and aircraft in future. India has developed an anti-radiation missile ARM that will help to destroy enemy advanced warning systems. This was named as Rudram-1, with a range of Production of the ARM is being done on a priority basis by the Defense Research and Development Laboratory DRDL, which specialists in missile development. Such missiles can be mounted on the Sukhoi Su-30 MKI fighter planes. Let's now venture into the realm of anti-ship and explore the fascinating intricacies it holds. Family name, type, maximum range, warhead, introduction, status, RAF, NASNSR, short range anti-ship missile, kilometers, conventional or nuclear, 100 TBD in user trials, naval anti-ship missile, MR, medium range anti-ship missile, conventional, 150 TBD in development, BRAHMOS, anti-ship cruise missile, 400 conventional or nuclear in service. Let's now shift gears and explore anti-submarine through a critical lens, uncovering its strengths and weaknesses. Family name, type, maximum range, warhead, introduction, status, REF, SMART, long range anti-submarine missile, kilometers, conventional, 50 TBD in development. As we transition to the next segment, let's unravel the mysteries surrounding research and development organizations and gain a fresh perspective. Current missile research and development in India happens under the Defense Research and Development Laboratory DRDL, and a group of laboratories collectively called the Missile Complex Laboratory Interim Test Range. Bharat Dynamics Limited manufactures the missile and also has an associated with Lab Composite Products Development Center. Defense Metallurgical Research Laboratory develops materials for defense and space usage. Drive APJ Abdul Kalam Missile Complex houses following 3 laboratories. Advanced Systems Laboratory research and development on motors, jet vanes and structures for launch vehicles and missiles. Research Center Emarit develops navigation and electromechanical actuation systems. Defense Research and Development Laboratory DRDL, famous for its contributions to Integrated Guided Missile Development Program IGMDP. Develops mission control software and among other missile-related technologies. High Energy Materials Research Laboratory develops propellant and explosives. Missile Complex Laboratories. These laboratories were earlier part of the DRDL or set up under them, but all are now independent entities. Missile Systems Quality Assurance Agency Vehicle Research and Development Establishment develops missile launchers. HTNP Industries develops hypersonic missile warheads, nuclear capable and non-nuclear capable. Don't forget to check out my other videos for more valuable content.